Jose Miguel de la Rosa Trevin from Stockholm. So I've got my Jose has a degree in computer science from Havana, and then spent a long time in the Carrazzo lab in CMB in Madrid, where he was one of the main developers for XMIT. And in 2013, he started leading the development of Scipion, and he's now moved to Swedish National Cryo-EM facility in Stockholm, where he's working on software development, especially on automation. So, Jose, do we have you live and sharing? Hi, Jose. Jose, take it away.
So can I start sharing my screen?
Yep. So I think you're live.
Yep.
Yep.
So, well, this is my second time in the CCP-EM Spring Symposium, and I'm as excited as the first time. So in this occasion, I will especially thank the organizer for responding so quickly and adapting to these times and changing the format and all the work that I guess all this require. Of course, I guess many of us will miss a little bit the beers and the social events, but anyway, this new format also have a lot of benefits. So I guess more attendees can follow the talks, and of course for the environment have many benefits. So today I would like to present some of the new developments we have been working for Scipion 3. Especially works that we have done in the core for preparing the framework for the future and to become more and more a collaborative software framework. Before starting with the presentation, so I would like to mention that I work at SciLife Lab in Stockholm. So SciLife is a consortium between 4 of the main Swedish universities. In our case, we are affiliated with the Stockholm University. So this SciLab is a national hub for different facilities, but there are also research groups. So this creates a really creative and dynamic environment with feedback and interaction between facilities, with more focus on services and delivering results, and also research groups. The national Cryo-EM facility also has another node in Umeå, so we kind of share and we provide access to the microscope and data processing for the Swedish community in the country. So in that sense, we have been also focused on software development and the development of different techniques for serving our community. So in this talk, just as an overview, I will have like 3 main points. First, I will briefly just present Scipion, what it is, in very short terms, and especially thinking about different perspective or interest when you are using this framework, this software tool. Then I will go a bit more into what we have been working on for this new version, Scipion 3, especially like refactorization, new wave of installation, and migration to Python 3. And then I will use some examples of new workflows or new plugins or new method that has been developing using all this infrastructure that showcase somehow the importance of this work that we have been doing for improving the internal structure. So if I have only one slide to say what Scipion is, I will say like it's something like this. So Scipion is a framework or an umbrella. So it provides a layer, unified interface for users. So when I say users, can be different things, right? One can be like you have your project with Cryo-EM data. Initially was mainly single particle data, and then you can do the whole processing. So you can start importing your movies, you do movie alignment, CTF estimation, particle picking, classification, and so on. And then the framework will provide a lot of options in different steps. So you will have, for example, in particle picking, many different programs that you can start using for picking, like Cryolo or EMAN, XMIT. And then, so below all this interface and all this infrastructure and visualization will be the actual program. So we deal with the conversion and execution of the program. So rely on programs, XMIP, system, or even CryoSpar that we have also integrated some tools. But then, of course, the interest or the focus is different. So you can have you can be an user with your data, but you can also be a facility, because in the last time we have been working in a lot of Cryo-EM data processing for on-the-fly processing. So the facility maybe is more focused on getting automated online processing. So more like having a real-time feedback. So in that sense, we modify the framework for allowing this type of processing. And then it has been quite successful in many facilities. So you have like a web reporting tools where you can see how the data collection is going, how your CTF estimation. We have pushed this also for particle picking and 2D classification. And of course, they are not limited. So there have been a lot of work in the team in Madrid and also here in Stockholm to try to push this to get an initial volume and even further to 3D classification. The other type of interest of users could be developers, method developers. So if you are looking into Scipion in this other kind of perspective, of course, you would like to have a lot of integrated tools for developing your methods. And then the idea we have been providing is like, okay, try to focus on the method, and then the framework will give you a lot of built-in tools. So like execution things, if you define, as it shows here, a script or a protocol we call with different steps, it's a Python script. And then from there, we will generate a graphical interface. We will know how to execute this step, the dependency between them, and then provide like restarting the protocol, distribution in a cluster or in a local computer, and many of these built-in tools. So the talk today will be more the work we have been doing for preparing the framework for this kind of users, for developers that want to add new methods and then try to reduce the burden of writing new graphical interface for analyzing the data and taking care of all this storage or database or conversions. So one of the tasks that we started in this new version was like a refactoring. So in the previous version, in 2.0, we focus a lot in pluginization. So we have before all the code in a single repository. Even if we design it like the code for each of the programs will be like a package, the code in practice was all together. So in the previous version, we did this pluginization that we call, and then we separated in different repositories and different code base, each of this code. And then in practice, each of these plugins, for example, for EMAN 2, they have like different submodules, one defining some content. You could define objects. The object will be like input and output for the different execution of different programs. And then you could also define viewers and conversion routines. And then all these plugins relies on a core thing that we call PyWorkflow. But then inside this PyWorkflow, we also define things that were specific to Cryo-EM. So in this new version, we focus on refactoring this. So we try to modularize this even further. So we say, okay, everything that is here in PyWorkflow is not related to Cryo-EM. So there is a part of this where is independent of the Cryo-EM field. So it's more like infrastructure, like storing in the database, defining objects, taking care of the workflow. And then there is another part that we call Scipion-EM, where we start defining these EM-specific entities, like objects, protocols, and viewers. And then these two are more like libraries, Python libraries that you could use either from a graphical interface or from other software. So it's not only like an application. So we put the application logic on another module. So this allowed us to go to the next step for making more standard ways to distribute all these different parts of the framework. So you have the whole thing, the whole infrastructure that users can use. But then now we have modularized even more, and then allow us, for example, in the installation part, to use more standard ways. So we can install now Scipion using Python virtual environments. So you can try in different environments, or you can also use Conda, that is also very popular in data science for different purpose. And then each of these plugins and modules can be installed as modules. So it will play much nicer with other tools in Cryo-EM or in general scientific environment. And so a lot of effort as well was put into migration from Python 2.7 to Python 3. So this year was the last year where the Python 2 will be supported. So this means that we will phasing out if we didn't jump into this new Python version. I have a lot of advantages. Like many scientific libraries will stop support for Python 2, so there is no way we can keep up like using these libraries, and many improvement in the language itself. So also for developers, there are many other benefits. So we have this plugin manager, so it makes very easy once you install Scipion to update these plugins without command line, so you can do it in a graphical interface. From a developing perspective, we put a lot of effort in automatic testing. So it means if you create new methods, we can host this in the Madrid servers where automatic testing is being run, and then you can detect errors more quickly. And then also if the user consent and want to send some statistic, we can like rank the protocols or the tools that are used more often, so that you can focus more on those and try to improve the more critical one. So in this new version as well, it's not only in the core, but also the XMIP team in Madrid has worked a lot in a lot of machine learning methods for different steps, for like movie alignment, also like local resolution and many other tools. So I will not enter too much into detail. We are planning also to support the new version of Relion 3.1 in the Relion plugin version. We have created a plugin for system, and more protocol has been integrated for the CryoSpark. And then of course for on-the-fly processing, there are like more monitoring and more tools that for facilities. One of the big additions to this new version is a tomography. So before was mostly entirely single particle. So we started like creating a data model like TIL series, tomograms, subtomograms, and then with this data model, we start adding more programs for doing all the pre-processing, like aligning the TIL series, building tomograms, and then subtomogram averaging. So we have tools for iMode and many other things. So keep an eye on the new release, that you will have a whole workflow as you see here in this image for tomography processing. Also, my colleagues in Madrid, and another natural extension of the single particle processing workflow was the atomic model building and refinement. So this work was done mainly by Marta Martinez and Roberto Maravini in Madrid. So they again generated the data model and start adding tools and protocols. So you can see here that now most of the steps in the model building workflow can be also be done inside Scipion. So if you are interested in learning more about this, you can find tutorials that are available in the Scipion webpage. And we have also a workflow repository where you can find not only for atomic model building, but for anything like the workflow itself. So this is nice for reproducibility and also learning what other has done and what parameters are used in different conditions. So there is a publication of this that if you are interested, you can go and read more about this type of workflow in Scipion. Another example that I wanted to mention is this LocalRec plugin in Scipion. So this was one of the first collaboration we had with external developers, with Juha Huiskonen. So he was at that time in Oxford, and with Serva and Ilka, he came to Madrid and we started doing this LocalRec plugin into Scipion, and was very successful because we could reuse many of the visualization tools. Like for example, the particle picker, we use it for showing these subparticles. In this LocalRec, the idea was like you could define symmetry vectors and then extract subparticles. And this has been quite useful, like for analyzing for symmetry mismatches. So there is a new publication that has been accepted, and a new version of the plugin that you can probably could read very soon, where different data has been processed. For example, this adenovirus, where you can see these trimeric fibers, and then tackle the problem of this pseudo-symmetry or symmetry mismatches. And then one last example that is a bit special in the sense that it's not Cryo-EM itself, is a micro-ID. So from yesterday, you heard a talk about from Honji, that is a Stockholm University, and we have a collaboration ongoing with SciLife Lab and the material department there to integrate these tools in Scipion. So our facility was starting collecting more data for micro-ID, and then for us was very natural to try to use this framework for this processing. Why to use Scipion? Well, when we were discussing with them, was many of the problems they had, or the limitation, like dealing with different file formats or command line programs that the user need to convert from one type to others, was very similar to what we had in Cryo-EM for single particles. So we started this work with Victor Benson, a PhD student from Stockholm University. And then he has started focusing on dials first. So he has a complete workflow now for these electron diffraction images. And of course, we want to kind of very easily repeat this workflow for different images and evaluate conditions. So this was kind of an attraction for him to use Scipion for this. And then similarly to other Cryo-EM work that we have done, the idea is that you can reuse the existing tools. For example, these are viewers from dials, how to show the spots and the reflections. And then you can reuse all these tools. So you don't need to invent everything from scratch, but just try to put everything together to make it the processing much easier. So as a summary of my talk, I must say that I'm very happy to see that Scipion is becoming more and more a community-driven project. So it's not a single group or a single few people who decide what is being developed or not inside the framework. So now it's more easy to extend and to add new methods. So the community can decide what to develop, if it is worth or not. And then for this new release, we have put a lot of effort in this infrastructure work. So this is not the most attractive one from a scientific perspective, but I think it's very important to consolidate the ground, to start building on top of that. And then of course, this haven't prevented to continue developing new workflows and new methods, like for model building, tomography, micro-ID. And then I hope like improving this framework will attract more developers. And of course, I still believe that collaboration is the only way to go, because in my opinion, it's not enough that we say that we have open source software if we don't put an effort into making it accessible also for other developers, and put some effort in making it like really integrated and easy to interact with other components, not only that it is open source. So with that, I would like to thank different people that has been involved in different projects, like CMB and Instruct Image Processing Center in Madrid, my former group, especially Pablo Cones and the Scipion team there, the XMIP team, also other collaborators in Miguel, Josue and Javi there, Grigory Sharov from the LMB that has been always very active and contributing to different plugins and very supportive also for users. And then also this good collaboration with in Helsinki now with Juha and Bahid and his group there that also has been contributing. And then of course my current workplace, SciLife, the whole Cryo-EM facility, Marta, that is very enthusiastic and always supporting new ideas, and Eric Lindahl. And then of course the collaboration with the Stockholm University, Victor, Honji and Shadow. So with that, I think I'm done and we'll be happy to answer any questions.
Thanks for the great talk. Yeah, we've got quite a few questions. So first off, you talked a lot about the improvements in the GUI, and then of course the first question is then from Pranav Shah saying GUI can be difficult over remote connections. Can you use Scipion without the GUI? Without the GUI?
Yeah, actually, yeah, I didn't explicitly mention this topic, but yeah, one of the additions to the new version will be like you could run small workflows or entire workflows from the command line. So, but if we think a little bit in Cryo-EM, at least in the current stage, in some point of the workflow involve user interaction. So imagine for when you need to select good particles from classification. So this, well, of course, if we have a method that can do this automatically, it makes more sense. But still, I think for the image processing type of analysis, we need to still like GUI. But yeah, of course, this is something we have been trying to make it more accessible.
Okay, and then there are several questions about tutorials and help in getting workflows up and running. So is there a complete tutorial workflow with dataset for tomography? And the same, almost the same question for LocalRec workflow.
Yeah, for tomography, I'm not sure if this is quite still under development. But yeah, we tried for many of the other workflows in Scipion to provide tutorials. So we have different types for model building. I know there is a tutorial. There is a link in the Scipion webpage. And for LocalRec, yeah, the paper is. I think after it is published, we will use the same data, or at least one of these data sets for a tutorial as well. And then we have different channels for helping the user. So there is a Scipion mailing list where you can like send an email there. And then we also have a Slack channel that also serve different type of users. So if you are a developer interested, you can join the different channels more related to development. And there are also channels more related to facilities, how to set up on-the-fly processing, or how best to use with a given hardware. So this is another channel of communication and support that we have. Yeah.
Okay, I think probably the last question then is a question about computation. So from several people, could you comment on computation? What sort of systems are required, in general terms, in terms of memory, GPU, etc., to make this work? And as a follow-up, can you use Scipion Cloud on free type of AWS access by Amazon?
Yes, well, from a computational perspective, Scipion itself, it does not require many resources because it's more like a manager. So it's mostly coordinating the different programs. So I think this goes down to what type of processing you want to do. So if you want to do like motion correction, of course, you will need a GPU if you are using Motion Core or Cryolo, or if you are using Relion, depending on what type of job, you will need more memory or CPU. This is something that we have also in mind for the future. Try to orchestrate between different computing nodes and making like smart decisions, or helping moving the less amount of data between these hosts. So in that sense, Scipion does not require much of a computational needs. And then, yes, we have run many workshops in the cloud. And then we have tried also using different remote visualization technologies like VNC in a browser. So it's quite nice from a web browser, you can connect and access all of these GUI things. Of course, it's not ideal in some case, but I think I will move more in this direction of remote computing.
That's great. Thanks very much. So there is a couple of specific questions about metadata handling in the Q&A. I'm sure you can.
Yeah, I will go through the Q&A and answer.
Thanks very much.
Okay, bye.